It is right now. A team of the world's most advanced chemists are sitting in a state-of-the-art laboratory. They have mass spectrometers, electron microscopes, and every chemical database ever compiled by human civilization. They can see the molecular formula on the screen. They can identify every single compound. They know exactly what they are looking for, and they still can't make it. Not because the ingredients are extinct, not because the recipe is truly lost, but because whoever created this poison understood chemistry, biology, and nature at a level that modern science, even today, cannot fully reverse engineer. That poison was made 60,000 years ago by a hunter with no written language, no lab, no instruments, no formal education of any kind, just a plant, a rock, and knowledge so advanced it has outlasted every civilization that came after him. This is the story of the world's oldest weapon and the secret it is still keeping from us. In 1985, archaeologists were digging through a rock shelter in KwaZulu-Natal in eastern South Africa. The site was called Umhlatuzana. Layer by layer, they went deeper into the earth and deeper into time. And buried beneath tens of thousands of years of sediment, they found something small, startlingly small. 10 quartz arrowheads, barely larger than a fingernail. They were cataloged, photographed, placed into storage. And then, for nearly 40 years, they sat in silence, waiting, until Sven Isaksson, a professor of archaeological science at Stockholm University, decided to take a second look. What he found didn't just rewrite the record books, it raised a question that no one in the scientific community has been able to fully answer since. Isaksson and his team applied the most advanced chemical analysis available to these tiny fragments. Mass spectrometry, molecular fingerprinting, techniques capable of detecting a substance at the level of a few billionths of a gram. And there, clinging to the surface of those 60,000-year-old quartz tips, they found it, a dark, ancient residue, still present, still chemically intact. 2 specific compounds, buphanedrin and epibufhanicin, both alkaloids, both belonging to a single plant still growing today in southern Africa. A plant known locally as gifbol, called by some the Bushman's poison bulb. Its scientific name is Boophone disticha. 5 of the 10 arrowheads still carried the residue after 60,000 years underground. How? Because these alkaloids possess an extraordinary chemical property. They do not dissolve in water. They resist degradation. They endure. It is almost as if this poison was specifically engineered to last. But stop and ask yourself, how did a hunter 60,000 years ago know that? How did he know which plant to choose? How did he know how to prepare it? How did he know it would work? The answer is more unsettling than you might expect. Let's talk about what this poison actually does, because it is not simple. It is not a fast-acting kill. That was never the point. Boophone disticha attacks the nervous system in stages. It causes severe nausea. It triggers respiratory paralysis. It destabilizes the heart, disrupting the electrical signals that keep it beating. And critically, it does not do this in seconds. It works over the course of hours. That delay was not a weakness. It was the weapon. These hunters practiced what researchers call persistence hunting. The arrow didn't need to drive deep. It didn't need to cause instant trauma. It needed to scratch the surface and get the poison into the bloodstream. So the animal ran, and the hunter followed, for miles, for hours, across the open African landscape under a blazing sun. But here is what that hunter knew with absolute certainty. Before he ever fired the arrow, the animal was already dying, invisibly, slowly, inevitably, and soon it would fall. In persistence hunting,